Hi, and welcome to a brand new video. Last time we discussed if we have a Sudoku board, whether to determine whether it was valid or not valid, which basically means whether the numbers in a row, column, and in one of those 3 by 3 boxes only came up once, right? Remember, numbers 1 through 9 only come up once in all those 3 scenarios. So we were able to solve this problem, and if you didn't watch this video, I super recommend that you do before today's problem, which is actually solving a Sudoku. And I know that it might sound intimidating, but we can actually use all the tools that we've already talked about on this series, plus one more concept called backtracking. Backtracking is basically when you put in some random value. So let's say here I just put in 8. And then you notice, hey, there's a conflict between this column, right? There's 2 8s. So you're like, there's a problem with my assumption. So then you go back and you change your assumption. And then you're like, oh, now there's another conflict. And then you change it until you get the right value for that index. And if you don't have any conflict, that means your assumption was correct. So that this method is what we essentially call backtracking, and we're going to be using it today in order to solve this Sudoku. So once this is just going to be our test case, but let's get started. So the first step that we're going to want to do is determine how many of each number we already have in the Sudoku. So in order to do that, it's basically pretty much a copy paste of this code. What we're going to do is going to create 3 global variables, private, and this time we're going to make them Boolean 2D arrays. We're going to create one for rows. We're going to create one for columns. And we're going to create one for boxes. And then inside the main method, we'll just instantiate that to be new Boolean arrays with 9.9. I'll just copy this so that we don't have to paste it over and over. So that would be calls equals and boxes equals. And if you're doing it static like me, just don't forget to put that static modifier on your variables. The next step that you're going to want to do is iterate through board and see which numbers you already have and which ones you don't. So actually, in order to do this, I'm going to copy paste this code from last time, and I'm just going to paste it right over here. All right, perfect. And we can actually just delete this middle portion. All we need is this part in which we just change these to true, because now instead of an int we're using a boolean. So what we did here is that this will iterate through board and see which numbers we have in each row, column, and box. And this will be very helpful for when we're solving it, right? So that we don't have to resolve this every single time. We already have this inside these arrays. So next, what we're going to do is we're going to create another method. This other method is going to be where we're going to be doing backtracking. So I'll do private static. This is actually going to return a char array. Backtracking. And it's going to be taking in 3 parameters. We're going to first take in the board. Next, we're going to take in which row we're at. And next, we're going to take in which column we're at. So the reason that we're returning a char array is that at a particular point inside this method, if it is a working solution, we'll return the array we're currently using. Otherwise, we'll return null. And having the switch will allow us to say that, hey, if it's null, it's not, our assumption was wrong, let's go back. And if it isn't, we're like, oh, hey, our assumption was right. So that's why we're returning the char array, so that we can make that decision in one point inside the method. So first, we just need to take care of a few base cases. If call is equal to 9, we just do call is equal to 0 and row plus plus. So because we're iterating through just normally like this, and then if row is equal to 9, all we need to do is return board. So now those are just our base cases, and now we are able to get into the juicy stuff. So what we're going to do is we're going to create a 2D char array, and I'm going to call this R. And I'm going to set it to null. And remember, like I just talked about, this is going to be our switch. If it's null, that means our assumption's wrong. And if we set it to something different, that means our assumption is working. And then we'll set it null later if it stops working. So then we're going to do stuff here. So I'll just write do stuff. And then at the very end, we're going to return R. All right, so what do we do in do stuff? Well, we're going to iterate through the numbers 1 through 9, and then we'll test to see whether we can use any of those numbers. So we're going to do int I equals 0, int I is less than 9, I plus plus, and we're using zero-based indexing here just because everything else we're using is zero-based indexing, but when we actually put it inside the array, we'll turn it +1. And the first line of defense is whether we already have in the row, column, or boxes. So if rows of row and I, which basically means if it's not in the row, and we need to say if it's not in the column, and if it is not in boxes. And remember, boxes has this weird index, so that's why I'm just going to copy it so that we don't have to retype it over and over. And I'm going to change this to row and column. And if it doesn't make sense why we have this weird index here, make sure to watch the previous video because I explain it there. So if it goes through a first line of defense, that basically means that that number does not exist inside the row, column, or box yet, which means it could be a possibility. So now what we're going to do is we're going to assume that it is. We're going to make our assumption that it is the number that we're looking for. So we're going to set rows of row of I to true, calls of call of I to true, and we're going to set this here to true as well. Next, what we're going to do is now we need to see whether or not our backtracking makes this valid, which basically means what we're going to do is we're going to say if, actually, no, we're going to set R here to backtracking of board of row of column. And if array is not equal to null, then we'll return array. There's one minor thing that we're missing here is that we need to change board, right? If we set this to true, we need to change board to reflect it. So we're going to set board row of call to be I plus 1 plus this char at 0. So this is basically a complicated way of setting it to be I. So now that we have made our assumption, we've rerun the method to see whether this assumption works, and we return array if it does, right? Because that means that we return the board. Remember here, we return the board if you go to the end and it works. So if it goes to the end and works, we just return array, right? Because that means our assumption was valid. Otherwise, we need to redo all of our work. So I'm just going to copy all of this and we can set it all to false. And that means that we can, and then as it continues through this for loop, it'll check the other numbers to see whether those work. And then at the end of the array here, if it doesn't work after this for loop, then we're just going to set board of row of call to a dot so that when we do come back to it later, then we know that we didn't set that number yet. So that's technically the method. Just kind of as a review. We first checked to see which numbers were remaining inside each row, column, and box. And then we were able to use this backtracking method of making an assumption and fixing the assumption if it was wrong in order to fill in the board. So let me just see what this is saying. Oh, the very last thing that we need to do is actually call our backtracking method, which is kind of stupid that I forgot, but we need to call our backtracking method right over here, and we're just going to use our board and start at the first cell with the first row and the first column. So I'm just going to save this and I'm going to run it. And we're going to see that we actually have an error here. This is not what we want, so let's look through our code and do some debugging. Well, first, there are actually two things that we need to fix. First, when we do backtracking board of row of call, we don't want to rerun the same thing that we're currently at. We want to move forward with the process. So first, this needs to be column plus 1. Next, we need to say that if there's already a number there, we don't want to change that number. So if board of row of call not equals to dot, which basically means that it already has a number, then we want to return backtracking of board of row plus call plus 1. So we just want to move forward with the processing. And the reason we're doing call plus 1 is because we iterate through just normally as you would leave it left to right and then go to the next line. So now if we save it and try running it, and I'm just going to move this up, you're going to notice that we were able to solve the Sudoku. So yeah, hopefully this video was a little bit fun. I know that I've always wanted to create a program where you could solve a Sudoku, and congratulations, now you have. So hopefully you're able to learn from this video and thought it was pretty cool. See you in the next video.